In this video, we're going to talk about how to graph a quadratic. So before you attempt this lesson, there's a few things you have to be comfortable with. You have to be able to find the vertex of a parabola, because that's going to be required for a graph. You have to solve quadratic equations, because that's going to be required to find the x-intercepts. And you have to know basic graphing principles, just like what are we doing when we're graphing? How can we figure out points on a graph? All right, so the general strategy for graphing a quadratic function is y-intercept, always the best thing to do. You just plug in x equals 0 into your function and simplify it as you fit your y-intercept. X-intercept is when your y value is 0, so that means you're setting your equation equal to 0 and you're solving. So using all of our strategies for solving quadratics in order to find your x-intercepts. Right. Then you're going to find the vertex. All right, I taught two different ways to find the vertex in the video, so do whichever method you prefer. I find the vertex of the parabola. And then put all those points on your graph, and you connect them with the parabola, so they should look like a U shape or an upside down U. All right, so let's go through an example. All right, if I look at this problem, I know, well, let's actually just do it in order of the strategy. So step one is to find the y-intercept. I find the y-intercept, I plug in 0. Order of operations, simplify inside the parentheses first, then the exponent, and then subtract. So my y-intercept is 5. I'm going to put that there. Step 2 is my x-intercept. I take my equation, and I set it equal to 0. And now I have to solve this equation. All right, this is where all our different strategies for solving quadratics is useful. Here I recognize I can use square roots. So I'm going to add 4 to both sides. I'm going to use square roots to cancel out the exponent. And don't forget the plus or minus whenever you do a square root. And then I have to add 3 to both sides. Again, that plus or minus just means there's 2 different answers, so I can do 3 plus 2, that's 5. 3 minus 2 is 1. So those are going to go on my graph as well. I have an x-intercept at 1 and an x-intercept at 5. And the vertex is either going to be the simplest or the hardest one. When it's already in vertex form like this one, it's the simplest one because I just know the vertex is that minus 3 in the parentheses tells me it's positive 3. That minus 4 tells me it's negative 4. So if you know how to find the vertex in vertex form, all right, it's 3, negative 4. All right, so now I have my 4 required points. If you were able to see the shape of the parabola from this, you can always plug in more points, but I can see the shape of the parabola. It has to go down through here. Remember, it always turns at the vertex. That helps you a lot too with knowing where your graph is going to be shaped. All right, here's another example, slightly different form, x squared minus 2x minus 3. All right, our y-intercept is first. I plug in 0. And this one is even easier than the last one because everything just goes away and I get negative 3. So negative 3 is my y-intercept. Next is my x-intercept. I set it equal to 0 and solve it. All right, this one I can't use square roots, but this one I can factor it. I'm looking for 2 numbers that add to negative 2 and multiply to negative 3. That's going to be negative 3 and positive 1. That's my perfect pair. And since I can do the shortcut method of factoring here, I can go straight to my factored form. I'd separate this into 2 separate equations. I get 3 and negative 1. All right, so those are my x-intercepts. Let me put those on the graph. 3 and negative 1. And the last step is finding the vertex. I'm going to start off with x squared minus 2x minus 3. And I have to do completing the square. All right, so when we do completing the square to find the vertex, first thing I do is factor out the a value, but there's no a value there, so I can skip that step. Next step is to know that b is negative 2. b over 2 is negative 1. b over 2 squared is positive 1. So my equation looks like x squared minus 2x. I have to add 1 and then subtract 1. Then those first 3 terms are going to turn into my perfect square. And the last 2 terms are going to combine. So my vertex is 1, negative 4, which is there. And knowing that the vertex has to be either the lowest or highest point, it helps me know that my graph is going to look like that. So that is the graph of this quadratic. All right, I'll do one more before I have you try one on your own. Again, you can try this one on your own without me if you just want to pause the video now. All right, but I'll go through this one in detail. First thing, y-intercept, plug in 0. This one you just have to be careful with your order of operations. Simplify in the parentheses first, then do the exponent, then multiply, then combine. So negative 34, so that's really far off my graph. There's no way I can graph that. All right, my x-intercepts are next. This is when I take my equation and set it equal to 0. I can use square roots in this one because I have this thing being squared. So I'm going to add 2 to both sides. I'm not going to write out the steps like I normally do because I'm running out of room. Then I would divide by negative 2. Then I would take the square roots here. I can write that out because it doesn't take any extra room. On the right, I get the plus or minus. The square root of negative 1, that is the imaginary number I. And I add 4 to both sides, 4 plus or minus I. So 4 plus or minus I are not real numbers, so there's no way I can put them on the graph. So this one has no x-intercepts. And the last thing I need to do is find the vertex. It's in vertex form, so I'm just looking at kind of this part here. The vertex is going to be 4, negative 2. So 4, negative 2. Let's see. 4, negative 2 is there. My y-intercept is all the way down there. And one thing to recognize is that there's this negative sign here. We learned this about transformations. A negative sign is going to take your parabola and flip it upside down. It also makes sense because this, from my vertex, I had to go all the way down to my y-intercept. All right, so there's no x-intercepts. The y-intercept's all the way off the screen, but I do have my vertex correct. And that's really as accurate as you can get this one, unless we were to like zoom out and make a bigger axis. All right, so here's one for you to try on your own. Go ahead and graph this quadratic function. I'll show you the solution in 3, 2, 1. And here's the solution. All right, the y-intercept is at negative 6. The x-intercepts I found were at 3 and negative 1. And the vertex is at 1, negative 8. So barely made it on the screen, but it's just there at the bottom. And that's the graph of my quadratic. All right, so go ahead and practice. This lesson uses a lot of stuff that we've learned, how to solve quadratics, how to find the vertex, how to graph in general. All right, so it's pretty comprehensive learning objective, but you've already done all this stuff before. You just kind of have to remember the different pieces and try to keep everything organized in your head.